Let's explore this imaginary unit a little bit more, particularly with exponents. We already know that I is the square root of -1. And this is also I to the first power. We've also seen from multiplying that we can take I squared, and by squaring the square root of -1, I squared is really -1. I to the third power is really I squared times I, but remember I squared is -1. So I to the third power is -I. This begins to explain my earlier comment that if we have powers of I higher than 1, we should rewrite them. But it doesn't tell the whole story. We need to look at I to the fourth power. I to the fourth power, we could write it as I squared times I squared. But we know from above, I squared is -1. And -1 times -1 is +1. If I go all the way back, any number to the 0 power, any number to the 0 power is 1. But notice, I to the 0 power is equal to I to the fourth power. And what that means is, if we try I to the fifth, we could look at this as I times I to the fourth. We already know that I to the fourth is 1, so I to the fifth is I, which is the same as I. We have a pattern. We have a pattern that repeats. This actually isn't something that new. We have a pattern like this in the real numbers with -1. -1 to the 0 power is 1. -1 to the first power is -1. -1 to the second power is 1. It's just that with -1 we repeat earlier. We have a pattern of 2 for -1, where I has a pattern of 4. And this becomes really important because if we look at any power of I now, we can find out which one of these 4 it represents. I to the 0, I to the first, I to the second, or I to the third. Let's see how we would do that. Looking at powers of I, we can find I to the n, where n is any positive integer, just by dividing n by 4. The remainder tells us which power of I we have. So for example, I to the 0 equals 1. That's if our remainder is 0. I to the first power is I. That's a remainder of 1. I squared is a remainder of 2. I to the third is a remainder of 3. Let's do the first 2, and then I'll have you pause the video. Actually, I think we'll do the first 3 together, and then I'll have you pause the video, come back, and see if you can do the last 2 on your own. And we'll talk about how to do it using our calculators to make it a little bit easier. 3I to the third power. I to the 0 is 1. I to the first power is I. I squared is -1. And I to the third is -I. Oh, I to the third is -I. 3 times -I, we can rewrite it as -3I. For I to the 40th, you may recognize that it is a multiple of 4. 40 is a multiple of 4. So if we divide by 4, 4 into 40, we get 10 with a remainder of 0. Remember, the remainder is the important part. And so I to the 40th is equivalent to I to the 0 power, which is really 1. For I to the 22nd, we could try long division, and I will do it. 4 divides 22 5 times. 5 times 4 is 20. When we subtract, we're left with 2. 5 with a remainder of 2. Remainder of 2 means we have -1, so I to the 22nd power is equivalent to I squared, which is really just -1. I do want to take out the calculator for a moment and show how we can do this without having to do long division at all. Our power is 22. We're going to divide that power by 4. Notice we get 5.5. 5.5. Well, the 5 is how many times 4 will go into 22, but the 0.5 is a clue to the remainder. At this point, we could do one of two things. We could take 5, multiply by 4, and we get 20. You may know that. That one, well, 5 times 4 is 20. Take 22 and subtract 20 from it, and you get the remainder of 2. Or, you can notice that 0.5, that's the same thing as 50 cents, and 50 cents is 2 quarters. And that 2 quarters remainder, the 2, becomes our new exponent of the equivalent expression. Try I to the 19th power and I to the 101st power on your own. Pause the video, come back, and check your work. If we want to figure out what I to the 19th power is equivalent to, we can say 19 divide by 4, and we get 4.75. Remember, we want the remainder. The 0.75 is 3 quarters, so the 3 is what tells me my remainder. I to the 19th is equivalent to I to the 3rd, which is negative I. And then the last one, I to the 101st power, we could do long division to get a remainder of 1, or we pull up the calculator, 101 divide by 4, we get 25.25, 1 quarter after the decimal, remainder of 1. So we can say I to the 101st power is equivalent to I to the 1st power, which is just I. And there you have powers of I. No I should ever be left with an exponent higher than 1 because of the cyclical nature of our powers of I. Your last activity is just a bunch of different problems, adding, subtracting, multiplying, and dividing on complex numbers. Try them on your own. There's a little multiple choice up here. You're going to match. You will use them again and again. Try these and check them with my OneNote that's posted and see if you got the right answers. I'm going to put answers only, though, so if you come across a problem and you can't find that mistake, know that you can email me. To illustrate the rich and beautiful nature of complex numbers, again, I do encourage you to look up the history of complex numbers. I have a few videos bookmarked on my YouTube page from someone else. I think it's a 7 or an 8-part series, but just working through the first 3 videos will give you a pretty good sense of history with these numbers. And also, I encourage you to check out the Mandelbrot set and fractals, and I will try to find a video to accompany this lesson on that and also put that in the playlist. Keep up the great work!